So in this problem of a homework chapter 11.1, there's a word problem, and they're asking for you to maximize where the cattle would be kept inside this fence. So a farmer is fencing a rectangular area for his cattle, uses a straight portion of a river as one of the sides, so he doesn't need to put a fence there. Okay. Note that there is no fence along the river. If the farmer has 2,200 feet of fence, find the dimension for the rectangle area that gives the maximum area for the cattle. So let's go back to here and take a look at the things that are important. So my important information, okay, one is they told me that I had 2,200 or 2,200 feet of fence, and this is actually my perimeter. Okay, so normally a perimeter for a rectangle is 2 times the length plus 2 times the width, but in this case we have a river, and so we don't need a fence up against the river, so actually it's going to be only one length. So length plus 2w is what it's going to be this time. So this is why it's just L plus 2w. Okay, because we have the river here, right? Here's the river, and so here's the fencing. So both sides are x, and that'll be my width. And then the length, I don't know what that is. So I could solve this for L, because I know the perimeter is 2,200, and L plus 2x, because W will be the x. So I'm going to solve that by minusing 2x to both sides. So L is 2,200 minus 2x. Okay, so now I know my L. So I need to maximize my area. Well, area of a rectangle, right, is length times width. I know my length and I know my width. So it's going to be 2,200 minus 2x times the x, because this is my width and this is my length. So I could call it as h of x, and I'm going to flip it to the other side. And so now I'll just distribute, and so now I'll get 2,200x minus the 2x squared, and that'll be my h of x. So they want me to maximize it, so that word maximized is telling me vertex point. So I need to find the vertex point, or at least the x value, because that's going to be my width. So I just need to find the x. So x is equal to negative b over 2a. The b in this equation is actually the 2,200. So that's 2,200. And the a is the negative 2. So I have negative 2,200 over 2 times the negative 2. And so this gives me a positive value. This is 4, and 4 into 2,200 is 550. So W is going to be 550 feet. So I know what this is, 550 feet. To find the length, that's this equation back here. So that's the 2,200 minus 2 times 550. This becomes 1,100, so the length is going to be 1,100 feet. So here are my two answers for maximizing it. So That's basically how you do this particular problem. And it looks like it's not possible, but you do need to know the perimeter equation and how you have to adjust it. And you also need to know area, or you can't solve this problem.